Hi there. I noticed something funny recently. One of my videos now has 40,000 views, which is a lot. It's the most popular video on my channel. And it's a video about changing normal cars to electric cars by replacing the wheels with electrical engines integrated into it. And I guess it does demonstrate an idea. I had a concept of making that video. First I started to look for these type of engines, and actually they are really old. There's a wooden Mercedes electrical car from, I believe, before 1900 that has a wheel hub motor, that has a motor in the wheel. It's a very logical place because it's a low point of gravity, and of course, you know, it's just, let's say, a motor already turns. So if it's a brushless motor, as it is these days, it can be really very long-lasting and efficient. So another aspect of that transition or that use of technology in order to make cars electric is that it doesn't require all the cars in existence to be let's say demolished and broken and replaced 100% with a 100% electrical car, which of course will take decades to do that, because people buy old and used cars, and you basically have to have the global production of cars for 5 years in electrical cars, and then everybody has to have the money. So trying to do that, trying to get people to buy electrical cars or make it or incentivize it, is actually enormously cumbersome way of trying to achieve what you really want, which is that people basically propel and move themselves using electricity instead of gasoline or gas or diesel. It's a typical thing that is good for the economy, but the economy is the carbon credit economy, so it's bad for the planet. Everything that makes economical sense is a bad idea if you want to live wealthy in the future, because you're using up the primary resource, oil, gas, coal, and it doesn't get replaced by a miracle. It doesn't get replaced at all. It's simply running out. So, but there's other aspects of it, and that is very interesting, and maybe something that really interests people about it, and that is that it's about a distributed process. So if you want to turn all cars into electrical cars, you can do that by in every area, locality, there's a garage, and that garage will have electrical wheels with integrated electrical motors, which can be mounted on the normal wheel hub, whatever it's called, with the 4 bolts or the 3 bolts, whatever it is, and then with a little cable it will be electric and it will be a controller in the car. And that's not one, and the funny thing is, not one person can do that process, or actually will likely want to do that conversion, but millions, because everywhere around the world you'll have these workshops, and everywhere around the world people can try to make these wheels, and everywhere around the world people will mount them and will try to make batteries for it, and etc. So you basically are doing, you are moving towards a solution in a parallel way by definition, because your solution is replicable, low level, and actually it would start a global competition for who does it the smartest and who does it the fastest and cheapest material wise, and who gets the best result, and what does your car turn out to behave like if it's treated that way. It is basically similar to the patentless development of greenhouse gardening and agriculture in Spain, as is described by one of the biggest critics of the current patent system. And I have to look up his name, but he basically said, well, people always say that patents are good for competition and for innovation, but they're not. Because what happens sometimes, and what happened in Spain then, was that they basically had a huge desert area, but they found out they have water, plenty of water to irrigate, and so there was a huge boom of little greenhouses where they made tomatoes and stuff, and legumes, and I don't know what these things are called in English, but vegetables to export. And they actually were one of the biggest exporters to Holland, because we had a cucumber scare a few years ago, so all the Spanish cucumbers had to be destroyed. Most of Dutch fruit comes from Spain, And that was a process in which all these farms were trying new things, and they could all look at each other, and there wasn't any patent, because these Spanish people, the people involved, they either didn't care or didn't want to bother with patents of their technology. And it was very, very beneficial to innovation, because people could simply always, let's say, ride along on the shoulders of the best performing, and always look at each other, say, hey, this guy is doing something very right, and I can now use it. I don't have to pay for it. It is, and the same thing could happen with the development of, let's say, how to electrify my car, how to make it electric. But it can also happen with other technologies, how to make a good solar heater, how to make a good electrical solar panel. And there's a very fundamental relevance to this distributed development and fabrication. And that is that it is typical for the type of economy that we are then moving towards. And I can explain that, and I've talked about it many times, which is of course the Roboeconomy. The Roboeconomy is a concept of an economy that in which things are made mainly by machines, automatically, but these machines are not powered with carbon but with renewables, so that whatever they make doesn't require a lot of money to make. Of course, even the raw materials can be recycled automatically from waste using renewables, so that you have basically a place where you put all your garbage dump, and on that garbage dump are automatic trucks driving around, just digging up the garbage, going back to the main factory, throwing it into the little tombola drum, and filtering out the plastic and the metal and the glass and the different types of plastic, sorting them out, grinding them into pellets. All that's done with renewable power, so it doesn't cost too much. Well, what are you going to buy if all these machines are churning away using renewables? Because at the end of the whole process, you got raw materials for manufacturing, which you can sell, of course. So then, of course, there's some trade, but ultimately, in the robo-economical situation, that will be the process, so that all waste will be reprocessed, recycled, cleansed, filtered, distilled into new raw materials, because there is so much renewable energy available to do that, and that the cost of that are trend to zero. And that's in that economy. So robots make everything, they do it using renewables, and we repair the ecology also using machines, so that's robo-economics. The economical or the structure of that economy is by definition distributed. It doesn't have to be like micro, super nano distributed or something like that. So not everybody has to have a milk factory next to his house and a cow and a pig and all that stuff. That's nonsense. It can still be centralized, but it is easier, especially in the beginning when energy is very scarce and all these renewable sources are not in place, to have local production than distant production. So today, long-range logistics is only possible because the carbon is there, and if the carbon is not there, the long-range logistics immediately collapses. It's just over. So you don't have any benefit anywhere. There's no sense in, for instance, trying to get all the wages in the world on the same level, because you cannot let a Chinese person do your work. It's too far away. The only reason why that works right now is because we are in a carbon credit economy, and the carbon suppliers sponsor let's say the tearing apart of manufacturing and redistributing around the world, so that the money that flows creates the biggest margins for the people that handle the money. The people that handle the money ultimately are the ones that are lobbying for a structure of the whole system which makes them the most money. There's another reason why the new robo-economy is fundamentally distributed, and that is that the renewable energy is being distributed parallelly around the world. If it's solar and wind, it's local, and there's only a certain capacity and a certain amount of it locally. So if you want to harvest wind, you can put up a windmill, and then there's a limit to the amount of energy that you can get out of the wind at a certain location. That means that there's a limit to the amount of production you can do in a certain location, and so there's a limit to the sense of transporting your energy to another location. So that's a fundamental aspect of it. So that. And you see the difference with the current model, the carbon credit model, where the carbon comes out of the ground at a certain point or is distributed over certain locations and is actually distributed, fundamentally necessarily to be distributed, because there's experts that know how to get it and that control it, and it's a dangerous substance, and etc. It has lots of energy, so it can burn like a maniac. It's poisonous, so you have to do all kinds of stuff with it, and that's perfect for the current system, because there's something that they sell you and then you waste it, you burn it, or you use it. Maybe you heat yourself and you think that's very useful because you didn't catch a cold, but then you have to get new stuff. You have to go back to the gas station, you have to go back to the gas company, you have to go back to the electrical company to get new electricity, because it comes from somewhere. And you can see that that's the basic structure of it, because they do allow big solar parks, because the electricity from a big solar park comes out of that solar park through a central, let's say, electricity transportation cable, and so they can measure it and they can know exactly how much you're buying, and it is actually exactly equivalent to power from a gas-fired power plant or a coal-fired power plant. And the same goes for wind parks at sea, and so putting them all in big parks and big windmills far away, so there's a big cable, and that cable makes the energy behave exactly the way as it usually behaves when it's from fossil energy sources. But ultimately that's nonsense. Ultimately everybody can have his street with solar panels on the roof, providing it with exactly the amount of electricity that street needs, and maybe more. So maybe a little bit more for the baker, a little bit more for the fertilizer power plant, maybe a little bit more for the hospital, let's say for the taxi company, for the bus company. All these companies need power, and so you might be producing that in your street, but you don't have to, and actually at a certain point you can't anymore, because it's just the area is too small. And that's a little expose on the reason why. So the future economy, the robo-economy, is distributed, and you're basically entering that economy, because of course, let's say if you have your street, everybody in your street has solar panels for themselves because you take care of your own energy. You should be buying it. That's nonsense. It's quite naturally there can be a different attitude towards electricity than there is today. Like now, yeah, we buy it because how can we make it? And then you say, well, we make it. How can we buy it? It's the other way around. And then somebody says, well, we have all this laundry in our street. Why don't we make a laundry shop down the street, and we give the electricity to that laundry shop so it does all our laundry? And then there's a guy doing that all day, and maybe after a while we have a machine, so we put our laundry in a bag, and the machine sorts it out, puts it in the right machine, launders it, irons it, folds it, puts it on little cars, electrical cars that are charged with the same solar panels. They drive to your house, or they put it in your closet. So you come home where everything is done. And this is like a futuristic automated society, which people have been dreaming about, of course, in the 50s and in the 60s. But there's no reason, just, let's say, once again, people that think that we're going back to a rural economy and we all have to toil in the mud and die and be poor and paupers are wrong. We have had the 20th century, we have shitload of technology and science and knowledge, and we can do all those things very easily. So I can make hydrogen in my kitchen. I can make an aluminum battery in my kitchen. It will take about 10 minutes, and then I have a battery that runs on aluminum foil. I can make all kinds of electronics. I can find the electronics. I can make a resistor. I can make electronic chips. I can etch. Everybody can etch a silicon chip. Everybody has so there's no limit to applying that technology, and there's no limit to doing that distributed, and there's no limit to do that in an unpatented way. And I think that's the best thing to do to achieve a future. the Roboeconomy. So that video, just to come back to the topic, of course, is that video. I really appreciate people watching it. I think that in order to achieve that robo-economic future, you have to realize that you can very easily do that by making sure that locally everything is provided for, and that you basically make sure that the transition is made in a distributed manner, because then everybody can participate in making it work. If you wait for somebody else to do it, or you wait for some technology, or you listen to some futurist or some Bjorn Lomborg that says it is no use and blah blah, that has a different meaning for you. Then what that means is that you would like to be told what to do, and you think that somebody knows better, and there's no doubt that somebody will know better, but there's no reason to not do anything. It's you know, if you talk about that, and then I'll quit this video because it's way too long. And I have another video which is funny because, or it's not so funny. My camera dropped and the colors are now out of whack, and I hope I understand how to fix it. But it's a little movie about Rotterdam that I'll upload just for fun. But people will say I'm a professor at the university, and that triggers in some people that they listen. And that should not be, let's say, saying that you're even amongst professors, and I worked at university, that's never the reason to listen. The reason to listen is whether somebody is telling the truth, or somebody's saying something that you can check and that you consider the truth. Of course, that's all very personal, and you can have all kinds of discussions about that. But never in university you can say, I'm Professor such and such, and I'm telling you that quantum mechanics is just a load of bullshit. No. Nobody will listen to somebody for those arguments. So, and so basically, I would advise, final thought, that if you see a scientist talk on television and you don't grasp what he's talking about, just stop listening to him. And because you're trying to accept some truth based on his authority. That's never a good idea. It's much better to become a scientist yourself and start figuring things out. And of course then I know somebody that thinks that if he doubts what I'm saying, that he is already on his way to being smart. That's not smart, because science is a series of questions and answers, and you have to be capable of finding the answer. Otherwise, how can you ever check what anybody says? And so there's lots of questions that you can ask, but you have to only ask questions for which you can find the answer, because otherwise you're asking a question that somebody can tell bullshit about, because you have no idea how to check for the answer. See, and that's a mistake many people make when they approach science. I say climate change is serious business, and then somebody says, yes, but what if the Martians farted and we had lots of methane? And well, that's a nice question, but you have no idea how to check that, and you have not checked it. You only ask the question. Well, everybody can ask a question. That's not science. Anyway, thanks for listening. I hope I didn't wear your patience out, and I hope you enjoyed the next video, because it's really weird colors. And good night.